All right. Cody, got the coffee.
Hey there, guys.
Go over here.
I need a Caleffi coffee cup.
Okay, well, we will get started today. We've got kind of a merger of two different formats today. We're going to do the Coffee with Caleffi presentation with some elements of a series that we did last year called Talk Showdown. So we will have a camera in the shop here that we can demo a couple things related to the topic as we go through. So let me get started with a couple of the housekeeping slides. If you are having issues with audio, the best bet is usually to just log out of GoToWebinar and log back in. We do have a 800 number if you want to give that a try, but usually just logging out and logging back in is the best way to go. If you want a copy of the presentation, hit yes in the post-webinar survey, and then we'll also archive this on YouTube so you can go back and reference it or look at any of the other Coffee with Caleffis over the last 12 or 13 years at this point. So we might be 20. If you want a certificate of attendance, we'll email you one of those as well if you can self-report those in your jurisdiction. And then we have another announcement in the long line of AHR Innovation Awards. So we took home the winner prize for the upcoming AHR Innovation Awards in the plumbing category for our PressCal HP. So this is kind of a cool problem-solving valve for high pressure applications in either a single stage or a two-stage application. And then the current issue of Hydronics, number 31, is also related to pressure reducing valves. So that's a really good one to go into more detail about how you size and some troubleshooting things related to that. We've got the next issue of Hydronics. You can see all the back issues at hydronics.caleffi.com. And then kind of a sneak peek here, we just sent Hydronics 32 to the printer. So we'll have that ready to go for the AHR show, and we'll ship it around the end of January to the people that have subscribed. You can always subscribe if you want to on hydronics.caleffi.com. And then again, we'll be at the AHR show in February in Atlanta. That first week of February, I think, is the show this year.
6th through the 8th. Yep.
So we'll have a bunch of different education things going on live at the show, a couple podcasts and things like that too. Okay, today it's the three of us, so no guest stars today. It's the three Caleffi North America trainers today, and we're going to be talking about the 3 keys to hydronic separation. And today we are giving away a gold standard kit. So this is a new part number for us in the catalog that combines the DirtMag Pro and the discount all in one box. You can get inch or inch and a quarter with the different sweat or press tail pieces depending on what you're looking for. And it comes with that cool sticker, so you can put that on your toolbox or on a truck or on a boiler or something like that and tag us on Instagram. So, or on your forehead.
But here's the ultimate question, Max, is how do they win that gold standard kit? What are we going to make them do?
So you have to ask a very good question today during the webinar. So we'll keep an eye on the chat, and if you've got a really good question or comment, we're going to give that away at the end of the webinar to a well-deserving participant today. Must be present to win, so don't send in a really cool comment and then go out to lunch or anything like that.
And we know if you leave.
Yeah. Okay, so the agenda today, we're going to talk about what has existed for air and dirt separation in the past versus kind of a high performance version of all of these different things, and how to know when you need one over the other. What if you do everything right and still have an air issue? And then we'll talk more about system fluids as well. So what are we going to do to replace the fluid that leaves the system when we blow down a dirt separator or something like that? And in kind of a crossover with the Talk Showdown series that we did, Cody and I are going to get into an argument at the end of the presentation. So.
I was thinking about this, Max, and I think we're really just preparing for the holidays when we get together with all of our family members and this kind of thing. We're getting ready. That's what we're doing.
It's a Caleffi family argument that we're going to get into the presentation. And the good news is, unlike at a Thanksgiving dinner or something like that, or Christmas, the audience gets to vote to see who wins. So we're going to do a poll, and you can vote for the right answer, or you can vote for Cody at the end of the webinar. So we'll get started with that, and that'll be kind of in the last little bit. So send us your questions. We'll keep an eye on those on the second screen too, and read those out. So to start with, you want to talk a little bit about pressure in a closed loop system and kind of how a vent works to start with?
Yeah, so when we talk about pressure, we're talking about two different pressures in a closed loop system. One is what we call the static fill pressure, and that's the pressure that you get to decide what it needs to be, and it needs to be enough to lift the water up to the highest point in the building. So the number is 0.433 PSI, call it a half a pound of pressure to lift water up a foot. So if we want to go up 20 feet, use the number. If you round that up to 0.5, you'll get a little bit of positive pressure, because at the highest point in that building, at the top of the riser, maybe the boiler's up on the top floor of a high rise in New York City or something, we want to have at least a 5-pound pressure up there. And that makes sure that when we have a flow type of air vent, that we have enough pressure to make sure that flow goes up and seals tight against its valve. So there's a number, there's the math, there's a little graphic of how it works. The next pressure that we talk about is dynamic pressure. And that's the pressure when we fire up a circulator. If we had a gauge on the discharge of that circulator, it's going to add its delta P, its pressure differential, to move the fluid around through the loops. It overcomes the friction of the fittings, the pipe, the tubing, whatever might be in there. So static flow pressure, you check that with nothing running, you put that in, you decide what it needs to be. Dynamic pressure is what your pumps are going to add to the system. So anything, Cody, on that I put up?
No, I think you hit the nail on the head. I mean, there's, especially for the contractors in the room, you got that bullet point at the bottom. Always check your tank pre-charge. Okay, I don't care who the manufacturer is. You got to check them beforehand. And really, you know, even when you start comparing tanks to fill valves and things like that, you know, maybe your fill valve's set to 15, your tank's set to 12, or your vice versa. You know, we're seeing a lot of these European expansion tanks that are coming in pre-charged at 15 for some of the smaller applications. You just got to make sure that it's got the right charge in it for sure.
Yeah, and whatever the Department of Transportation allows you to ship a tank may not be exactly the number that you need for that system. So it's always good to verify there.
Yep.
Okay, so let's first talk about a high point air vent. So here are some different places where you might find a high point air vent. They are going to be great at getting air out of a system when it has slowed down. Maybe the circulators are off, so there's not a lot of turbulence and it's going to be more buoyant, and find a high spot. So it's great to have a high point air vent in all of these different applications here. It could be on the top of a riser, or the top of the solar panel, hydro separator, anything like that. But it is only going to catch stuff that's going to end up at a high point. So if you put 1 by whatever 1/8 inch T on a straight line of pipe with the pump running, that's not really a great spot for that. You're going to be moving too fast. You're not going to have enough space up there to collect a lot of air. So the air vents are going to be better for a high point to catch something that might get stuck in a heat exchanger, as an example. So let's look at a couple different versions of this, and if you want, I can kind of narrate that, and I'll turn on the shop cam over here somewhere. Okay.
Yeah, and the other thing to think about too is you mentioned heat exchangers. You know, the fact is that pretty much every boiler on the market is going to come with some type of an air removal device on the top of it. You know, they want to try to keep those boilers full of water, obviously not air. And not only that boiler is going to be one of the best places to actually remove air, because it's going to be one of the hottest points in the system, and that's going to be when air is less soluble in your water or your fluid, and so it just is ideal place to actually get rid of air.
So let's talk about radiator maybe specifically. So we've got a demo over on the shop cam here. We've got 2 different options for our manual air vent that has the hydroscopic discs inside of it. So you can kind of see into the belly of it right there. 2 different choices. So if you have a cup of, if you use like a little Tupperware or whatever you use to purge a radiator, you can do that with the manual setting, and then you can turn it so it's in automatic when you're all done with that. So then let's say another bubble of air finds its way into that radiator later, the air can come out, but as soon as it senses some water, those little gaskets right there, those washers will swell when they get wet. So it can be in automatic mode. As soon as it has water present, it's going to close. So then it's not going to drip. And then when it dries out again, it'll continue to purge air. So that's an automatic setting for a really simple device that has a little bit more complicated path on the inside there, instead of just a bleeder valve that you would have in the front of a pump or something simple like that. Okay, now let's talk about the automatic air vent. So this is going to be on the top of a lot of our different products here. we've got the linkage kind of pulled apart that you can see a little bit better. So it comes out of the separator like that, comes out of the air vent. And then let's say you start to notice that there's a little bit of water coming out of the top of that. We've got a couple different options for you here. So one could be that there's just a little copper shaving or piece of Teflon right in that needle right there. That's where you're going to find something that would hold that up from sealing well and keeping the air from leaving, or to allow water out of the air vent. So that little linkage there, when the air comes up, it's going to push the float down, pull the needle down, and allow some air out. As soon as it's full, then the water level goes up and it closes that little needle valve. So if you pull that linkage apart, you can service that really easily. And then the one thing to note is when you put it back together, make sure that that linkage goes back onto the pin, and you even hear like a little click there, so it engages the needle. If you don't get that on like that, then it's going to float without moving the needle, and that's not what we want. So Cody, do you want to tell us what's important about the air pocket up at the top there?
For sure, for sure. So when you've got that air vent, that float moves up and down, and as the float moves up, it's because there's water pushing up from the bottom, and it floats up with that water. Now, if you see a lot of guys in the field where they don't know whether or not the air vent's working, okay? So how else do you confirm that that air vent's working? You take that cap off the air vent and you push the needle down inside there. And what's going to happen then at that point is you're going to remove whatever air pocket is inside that air vent, which is great because then water will come out. You'll know that it's full of water, but the problem is that by removing that air pocket, any floating type debris that's going to be on the top of that water line is now going to be in your valve, your needle valve that keeps that air vent from actually leaking all over the place. And obviously that's what we don't want. We want to make sure that air vent's not leaking, but definitely don't push down on that needle valve in the top.
And then we show a little bit on this slide here, plan B. So let's say that you've got an air vent above a conference room table or some, expensive piece of equipment in a server room or something like that. And you just really don't have any option to have water come out of the top of that valve, even if somebody did put their finger on the cap and get a piece of Teflon tape in the top. So this cap, I'll walk over and show it on the screen here. This is shown in the cross section, or yeah, there you go. Give that to you. So that is the same kind of technology with those little fiber gaskets, those little wafers in there, that if you put that on the top of the air vent, and this will fit on other brands of air vents as well, same thing, it's going to swell when it gets wet and it's going to close. So if you had an air vent above something that was really critical, not just above a boiler that's above a floor drain or something, and you really wanted to make sure under no circumstance does water come out of the top of that, you can just add that accessory right over an existing air vent to make sure that you seal up when the water is present, if that ever becomes an issue. But like Cody said, if you don't collapse the air pocket there and there's not debris in the top, it may never happen. But I know that every contractor on the call has probably seen an air vent that is leaking a little bit at some point in the year.
It's also a great way to prevent the redecorating of floors with soggy ceiling tiles and things like that, So if it's above in a hallway or something like that, that great little cap is pretty awesome. Now, I'm glad you brought this slide up, Max, because there was a question that already got brought up. It was more of a comment than a question. It was every air vent should have a valve under it, a shutoff valve, isolation valve. And they mentioned, why don't yours come with one? Now, we don't actually include an actual like manual valve, but what you see there at the bottom there is going to be the service check valve. Now, that service check valve, what happens with that guy is as you thread on the air vent, it actually pushes a check valve open, allowing it to be open to the system. And as you start to unthread it again, it'll actually close off so you can service that air vent, replace it, do whatever you need to do without taking a bath or doing the famous hot swap where you're trying not to take a bath and everything like that, or lowering the pressure or whatever. That service check valve is great because it's very small. It doesn't take up a lot of room. And the fact is you can still service it without taking down the system. So I hope that answers that particular question about that. That's pretty awesome.
And you'd want to be careful if you use like a gauge cock, an 1/8 inch gauge cock, because I'll show you on our 1/8 inch vent, most of the vents have a little tab on the bottom of it. And that little tab is when you put it in the air scoop, it goes down into the flow a little bit. And I found if you screw that into a ball valve, sometimes that'll hit the ball in there, and then obviously it won't work. You won't be able to turn the ball valve on and off. So be careful with a gauge cock. It's better to use that service check than trying to screw that into a little mini ball valve, for example.
For sure.
And then we'll kind of come back to the anti-siphon cap. We've got a graphic to show why that's important, but you want the air separator to be purging air. You don't want it to introduce air into the system. And there are some piping things and expansion tank location things that could happen that would allow air to come back in through an air vent. And that's kind of what we were getting at with the, I thought I had everything installed right. I've got proper air and dirt separation. Why do I still have an air issue? That anti-siphon cap may be a good troubleshooting thing to have, one of in your truck as well.
And yeah, I think Mack said it does fit a lot of the other vents. I know it won't fit like a Made of the Mist. That's got like a regular tire thread, like a cap on your tires. But I know a lot of the other valves has that same thread, so you'd have to try and see.
Okay, so let's say we want to go beyond an air vent to something that's a high performance device that's actually going to catch little micro bubbles of air as they're passing through portions of the piping with the circulator on. We need to graduate to something like an air separator. So if you look at the cross section here, still just an air vent at the top, same linkage and everything. It floats on a pin right there, so it stays right in the center of the separator. But we've added something. We've added a collision media. So coalescing media is another word we use for it, and that means to gather. So basically with these sharp knife edges of this polymer collision media in the stream there, it's going to gather the bubbles, and as soon as they get to a bigger bubble size, then they can go up and out the top. And we'll kind of cover what those different categories of air are in a second as well. But that's the collision media right there if you haven't ever taken one apart. So just a lot of sharp edges like an eddy in a river that kind of catch and swirl and gather the bubbles, and then they'll float up and out the top. Same thing, we flip it over and it's a dirt separator where particles collide and fall to the bottom, which we'll cover a little bit more. Okay, so what type of air are we trying to separate? So stationary air pockets at high points, that's a great spot for a vent. That might be on the top of a heat exchanger for a boiler already, or in a radiator or something like that. That's a pretty easy one compared to the other topics. Entrained air would be like that milky look that you have in a glass of water when you pour a glass of water from your kitchen sink. That is going to be harder to catch those little milky micro bubbles as the fluid is moving really fast at 4-6 feet per second through a piece of pipe. That's not something that you're going to vent very well. That's going to go right through a scoop like this. And then the last one is gases dissolved within the water. And that's an even trickier one that relates to the temperature and the pressure in the system. And the gases dissolved within the water, you could have an air separator that's doing a great job for the first two, but it's in the wrong location and you wouldn't catch that third category. So those are a couple different things. Do you want to demo how the scoop works a little bit there? And then we'll move on to some piping related to that.
So this is commonly called a camel hump in the industry just because of the shape of it. I call it a coupling because really that's all it's really doing, it's coupling the pipe. And the technology inside one of these is, number one, it's a big space. So whenever water comes into a space like this, that's called a low velocity zone. So the water slows down as it comes through here for the brief period of time that goes through there. Notice there's a little ramp to try and encourage the air to go up to that little vent that would screw into the top there. And you can see the little tab that sticks down there trying to grab some of those little micro bubbles as they come through. But really you're dependent on the velocity slowing down. There's really no media. If you would have built this with this inside there, you would have had a great air separator, because now you've got these little veins that are catching the bubbles like we showed in the graphic on the slide there. But yeah, this is just intended to try and push the bubbles up where this can do its job to remove them. This one here has a port that maybe the expansion tank and the fill valve would hang on that. So you've got your expansion tank and your air vent, but it's certainly not a high efficiency type of device. There's just nothing in there to get those entrained air and the micro bubbles out if it was in right.
And personally, Bob, I think that those are really great for the air management systems. When they were the top, instead of having an air vent on it, it was connected to a compression tank. So if any air got out in the system, it would collect back at that air scoop and then take it back up to that compression tank. After that, like you said, without the coalescing media, without the ability to take out the microbubbles, you're not really doing that system any justice.
Yeah. Yeah, back in the day, the old boilers, the old cast iron boilers were air separators. In fact, some of them even had little sections that had little vanes and fingers in there to try and encourage air. And all you did is screw an air vent right through the jacket in the top, and did a pretty good job of getting air out. But that's not the case with a boiler like the one behind me that holds 1 gallon of water, and it's going through there pretty fast to keep the velocity up, to keep that heat exchanger. So, you know, high efficiency equipment needs high efficiency air and dirt removal. That's the bottom line to it.
For sure.
Okay, so let's talk about piping related to an air scoop as well. So can I put a 90 right on the edge of an air scoop? Is that a good practice?
As you can see in the picture, not really. I mean, most of them say, they used to say, depending on the size of the air scoop, 18 to 24 inches of straight pipe going into it. That way, you got a chance for the bubbles to start to separate and go to the top of the pipe as they get in there. If you're right at an elbow, you've got a little bit of turbulence coming around that elbow, especially if you're over pumping the system, which can happen, that the water is just not, you know, separating its air before it gets into the scoop. So that straight pipe on the front end of it helps the performance of them a little bit.
Yeah, anytime I typically see these air scoops installed in the field, they're usually not following the rules about the 2 feet of straight pipe beforehand, and it's kind of one of the worst things about the industry is that a lot of times you can have something installed that's not installed as good as it or as well as it should have been. It's still going to work somewhat, but it's not going to be as effective as it could be. And it's those best practices that kind of separate the good from the great.
Yeah, we don't want those air bubbles in our pump. We certainly don't want them in a little high efficiency boiler. We're going to overheat the metal of the boiler. And you don't want them in your radiators or your fin tube or your radiant tubing, whatever it might be. We want water touching all the surfaces, not little micro bubbles, because you reduce your heat transfer if you've got air of any type in your system, in your pipes and your radiators.
Yeah, we actually had a great comment come in. Does straight pipe, do we require straight pipe for the newer style coalescing type air separators? You want to take that one on, Bob?
No, you can put those right. And a question that came in also relates to that. On which side of the pump should it go? It can go right up against the fitting, an elbow, a T, whatever you might have. It can go on either side of the pump. We want the air separator, like Cody said, at the hottest point in the system. So the closest you can get it to the boiler or on the return side of or the outlet side of a return side of a chiller where the water is coming back warmer, that's the best spot for it. So it's not necessarily needs to be in the secondary loop. It wants to be in the hottest point in the system. But no, you can put an elbow on the inlet or the outlet side of this type of separator, the Discal, for example, or the combination Discal dirt.
And that's why that bell is so big. If you take one of the separators that we show there and put it next to some of the other ones on the market, or even an air vent or something like that, it's big because we really want that velocity to slow down quite a bit. So in the hydro separator, when the water goes into it, it slows down to about 1/9 of the velocity in that big chamber, and that's how we really effectively separate the air too, is that we just give it time to slow down so it can come to the top a little bit easier. So another category in commercial systems, generally big flange systems, would be a tangential separator. So this is something that works really well to separate the flow as it goes through. It kind of goes through in a big vortex, and it's going to bring the air to the center and right up to the top. The caveat is with a very specific flow rate. So if you have an ECM pump that might be between 2 and 200 GPM or something like that, you're going to separate air really well at the design conditions there, but not as well if you're just kind of sneaking it as a slower velocity, not as many GPM. You're just going to go diagonal, kind of lazy across the center of this. The big vessel itself will help separate air because it's going to slow down, but to get that full vortex effect, it has to be kind of at a target GPM, which it won't always be if you had a variable speed pump.
For sure. We also see some of those actually where they get installed with strainers too, which can really slow down flow if they get plugged up and things like that. And personally, especially on a heating system, I always like to see the air removal and the dirt removal in 2 separate spots, because that's where it's ideally placed, which we'll get to later, I'm sure. But definitely not good to have that thing all plugged up full of debris. So.
Okay, so let's look at the last category of air that we talked about with air separation, is the gases dissolved within the water, or the glycol. So how do we catch those? It's based on our air separator placement. So we want it in the hottest temperature with the lowest solubility. So in this simplified example of a piping loop here, this is the hottest temperature coming out of the cast iron boiler at 170 Fahrenheit at 20 PSI. So the pressure is low. If we were to put that air separator after the circulator, as was mentioned, can you put it after the circulator? You can. One of the issues is that you've really boosted the pressure there. So now we're up to 32 PSI, and basically we're forcing those little molecules of gas back into solution, and we won't be able to vent them as well. If we would have put the air separator just before the circulator, we're going to be at a lower solubility, so more of the molecules of gas are going to come out of solution, and we'll be able to vent them. So one of the things that comes up with this is, let's say it's a modulating condensing boiler like the one behind us, and you commission on a day in April. And it's kind of warm out, so the outdoor reset curve had a maximum supply temperature of 105 degrees Fahrenheit or something like that. You could still walk out that boiler with air later in the year, let's say it's on New Year's Eve, because now you're at a much higher temperature and you've had more air come out of solution. So you could have purged that bulk air really well, the entrained air you could have gotten out really well, but you have like hidden air left that you have to get out when it's at a high temperature. So one way to do that in the summer would be get it up to the top of your outdoor reset curve. It may be more than you need for the day, but if you're commissioning and you're there for the day in April, take that outdoor sensor off or put it into some sort of service mode so you get it up to a higher temperature, because that's where you're actually going to like bake the air out of solution and vent that out, and then bring in a little bit of makeup water and be closer to some zero air scenario, even though that's probably never completely realistic.
And then in this picture, the two vents work together. So we've got the, the separator back at the boiler at the good spot, the hottest point. Then you notice the air vent on the top of the, where the end of the fin tube is there. So that's position C. And if you look at the graph over there, that's the second best place to get it out because that's the lowest pressure. And that's also the point where in the off season, any air that you didn't get out is going to migrate up to that high point. And that's what that flow type of air vent can handle in conjunction with the separator.
Okay, so let's talk about that hydroscopic, that vent if at the top that you wanted to have the little check valve to prevent air from coming back into the system. So here's where that could happen. So best case scenario, we're always pumping away from the expansion tank. So we've got the expansion tank right here. Our circulator is after that. And in the green dotted line, you can see what that does to the pressure throughout this loop. So the pressure is going to start to drop as it comes around the bend, goes through the different fittings, comes back. We're down to 9 PSI before it's boosted up again. There's your point of no pressure change, right where the expansion tank connects. What changes when we have an expansion tank that we're pumping into? Do you want to kind of walk us around the loop here?
Yeah, and it's going to depend both on the circulator and the loop itself. But here's an example. This is an old Bell and Gossett drawing from 1960 something, I believe. But so what happens is when we pump at the point of no pressure change, the circulator is making its pressure difference from the suction side, from the inlet side, because it can't push water into the expansion tank. It can't compress it. It can't take water that's in there and squeeze it and make it smaller. So it says, well, the only way I know how to operate a circulator is I got to make a pressure differential. So it's taking it from the suction side. So that 10 PSI fill pressure, in this case on the right, we use the 5 PSI fill pressure. You can see what happens as we go around there. We're going down in pressure, down in pressure. We get to the third bend there. We're down to 0 PSI. As we come down to the end there, now we've got a negative. Now we've got a subatmospheric condition in our system. So if we had an air vent anywhere from 0 down to 2 PSI or anywhere along that, what's going to happen is when that pump kicks on, every time it kicks on, you're going to get that negative pressure, and that flow type of air vent will be pulled down, and you'll get a little sip of air, a little sip of air. So over the course of weeks or months, you get a call from a customer and said, the guy came over here and he purged all the air. He was here for 2 hours. He charged me. A month later, I got noise in my system again. And a lot of times it's this placement of this expansion tank. And what makes this worse, if they went to a job that used to have like a old B&G Series 100 pump, and they put in a pump with a little higher head, like a 1558, even a 007, add a little bit more head to that, you can make these numbers worse because you've added, a little bit higher head pump, and you can pull this pressure down to subatmospheric, maybe even sooner in the system. So it's related to the pump, it's related to the circuit, but that it's an easy thing to fix. Either move the pump to the other side or move the expansion tank to the inlet side of the circulator. And it makes air removal a lot easier, because if you've got a system with a 0 pound pressure, it's going to be hard for any type of air vent to work in that condition there. Remember, we wanted a little positive pressure to be able to push that air out. So your air vents are going to work. You're going to start your system much quicker with your pumping away from the expansion tank.
Okay, so how did we get here?
Yeah, so the air we breathe, as you know, is what, 78% nitrogen. It's mostly nitrogen what we're breathing. We've got 21 or 22% oxygen, some inert gases in there. It's the oxygen that's within the air that goes in your system with the water that can cause corrosion in the system. So in a perfect world, what we would have in our system is what's called dead water. And dead water is water that all the oxygen have been pulled out of it. It's really hard to maintain that in the system. Oxygen molecules can get in through non-barrier tubing, through rubber tubing, which is an example of that. They can get in around packings on three-piece pumps, packings on valves, or pump seals, stuff like that. So it's really hard to keep a completely oxygen-free system. A good air separator, of course, will keep it down to a minimum, but this is what happens when you have a system where oxygen is getting in on a pretty regular basis. You've got a high temperature system, you've got non-barrier tubing, and oxygen's getting in there, and it's going to go after any ferrous component. The weakest is usually the expansion tank because the metal's the thinnest there, and that's what happens when you see a job where there's a bunch of old expansion tanks laying on the floor when you arrive. Pretty much tells you've got an oxygen ingress, and it can happen through that air vent. Like I said, it can happen around tubing and stuff like that. And over here, this is a separator that was put in on a job. It was a rubber tube system that was put in 25 years ago, I think. This air separator was in the job for 18 months. And they got a call, and I've got a drip on the floor near my boiler, and this is what we found when they took it out. It actually pinholed, if you can turn a little bit there, Max, on the side, it actually pinholed right through the metal up there. I don't know if you can quite see it up by the port on the top, but a pinhole through that. Look at all the rust and deposit. And this was on a system that didn't have a fill system. It had a fill tank on it. So they said it wasn't taking on water. It's not like there's a leak somewhere. Every day a gallon of water was going in the system. It was a completely sealed off system. So all that corrosion that you see in there happened from the oxygen getting through the tube into the system, and just it went through a bunch of expansion tanks. This contractor that put this in, he said, I'm not the first one that worked on this. He said, I could tell by the expansion tanks that they had gone through it, that were laying around the room there. So that's why we want to, make sure that we've got a air and oxygen tight system as best we can. Now, there's a couple ways you can deal with that. You could put a chemical in there, and you could put an oxygen scavenger chemical in there that would take any oxygen that comes out, but you got to keep doing it. You got to replenish it every year or so. Or you could separate that and put all non-ferrous components in. Put a flat plate heat exchanger on the, the tubing side of it. Put a non-ferrous pump in there, a stainless steel pump, a stainless steel expansion tank, and just get all the ferrous metals out of there, and then there's nothing to corrode. But it's going to keep happening if you don't.
Oh, you're muted there, Cody.
Sorry about that. We had a good question that came in about hanging expansion tanks from the bottom of an air separator. We have a tapping on the bottom of our air separator, but they asked about the idea that is it possible for dirt and debris to actually come from that air separator and fall down into the expansion tank? And is that a problem? Is that something that needs to be addressed?
Yeah, certainly. I mean, again, think of that low velocity zone. So if there's any dirt or rust particles coming through there and it hits that little zone, it has a time to settle down. What happens, it'll go on the top of the diaphragm or the membrane or the bag type, depending on what type of expansion tank you have. It'll sit right on top of that. And then as that diaphragm tries to move in there up and down, you're kind of abrading on the top of it. So come down, put a T in with a branch off, and put your expansion tank off next to it instead of right down below it. I know it happens forever, but maybe it's not a huge deal, but certainly you want to do it where you've got a lot of dirt and debris in the system. Just avoid that potential problem.
Yeah, and in those scenarios too, I would say that if you've got a good dirt separator before the boiler and everything, how much dirt and debris should be at that air separator? It should be pretty much next to none, hopefully. So
a Y strainer, any type of device that's getting that deposit before it gets through your pump and your boiler into your expansion tank, which I think is next. Yeah.
Okay, so for dirt separation, there will be non-ferrous dirt in a system, even a brand new system. Sometimes we get those questions that, hey, it's radiant, it's a stainless steel heat exchanger. The only thing that's ferrous in this entire system that's brand new is the expansion tank and the volute of the circulator. Do I really need high performance dirt separation? So you could catch some of that stuff with any basket strainer or any dirt separator. The reason that I like a dirt separator in any case as kind of the back before your expensive components is you never know. We've had stuff come back with what, a welding glove in big steel separator, a little, you know, Lego guys, a lot more solder than maybe you thought you used in different installations, Teflon, or whatever wood chips and things might be, you know, in the truck on the yard of the supply house or whatever. So you never quite have everything clean, and you can catch it with two different methods. You can use a Y strainer. The problem is whatever you catch stays in the fluid path forever. So if you caught that welding glove, you now have to live with a welding glove obstructing your flow for the rest of time, unless you're able to get that out of there. We got the one returned back, and we had to, you know, pull the glove out after it had been shipped back to Caleffi, North America, in Wisconsin. So what I prefer is that we have that dirt hit something and fall down out of the fluid path, and that's what a dirt separator does. It's like it's grabbing the debris and throwing it into a bucket. So what you can do to get dirt out of a system is, it's a complicated process that may be very different for a 100-year-old building with cast iron radiators than it would be for that brand new radiant heating job. But a good start is some sort of chemical flush. And we'll go into a little bit more detail with this at kind of the end of the presentation. But you flush out a system with, you know, essentially a soap to get some of the grease and some of the just process stuff out of the system, for a lack of a better word. And then using a basket strainer is good, but it is going to plug. So basket strainers, you've described them before as like a point of use protection. So maybe you still have a basket strainer by a fan coil or by a balancing valve somewhere out in a big commercial building, but the point of distribution, that's a great spot for a dirt separator, because that's where we're going to protect our most expensive components, and that's where we're going to, you know, have a combined flow rate for the entire system. So maybe a 2-inch flanged is a good fit there, where you wouldn't put, you know, 1-inch dirt separators in 20 different fan coils in a building, as one example. Okay, so Cody, do you want to kind of narrate this flow chart with the Y strainers and the different flow penalties that you'll have?
Yeah, for sure. I mean, you know, I talk to a lot of contractors and a lot of people that are very familiar with forced air type systems and everything like that. And you might even have one in your own home. I mean, you've got an air filter in there. How much air do you think that system is going to be able to flow if the filter's clean versus plugged? And that's the whole idea with a strainer is, you know, when you've got a strainer, when it's brand new, that's your best chance for the most flow that you're ever going to get through it. As it starts to plug up over time, you know, your flow rate's going to decrease, or if you've got a variable speed circulator, your current draw is going to go up because it's going to start ramping up on top of it, but sooner or later it's going to plug up. The problem with a strainer in these systems is that you can't just pull it out real easy and look at it like an air filter in a forced air system. You've got to be able to get that system wet. Now, when you look at that strainer in the upper right corner, that's not just an easy blowdown on that strainer. You're yanking that thing out of there, you're banging it on the ground, you're washing it all out, and more than likely you're not going to have, you know, isolation on either side of it, so you're isolating large portions of the system or even draining down the system in some cases. But like Mack said, is that when you have a dirt separator, all that dirt and debris falls to the bottom of the cup in that basket, and it falls outside of the flow path, which means that you're not going to be interrupting any flow, causing any more unnecessary pressure drop. It's going to be great for your system. Not only that, like Mack said, it takes out smaller particles than what that strainer is capable of too. Which is all in all a good thing. So
when we talk about pumps, we say you never want to put a flow restricting device on the suction side of a pump, but that's kind of where you'd want your Y strainer. But if a Y strainer ended up in that condition there, that pump's not going to be very happy. You're going to be cavitating that pump, and you're going to have pump problems in addition to flow problems in the system if you don't. You can see at 70% plugged up there, you can see what the pressure drop when, if you had a pump that's only developing 10 PSI or 10 feet ahead, it's barely going to go through that strainer when it's plugged up that much. So,
and then let's say you have a basket strainer there's still debris getting into a circulator, into a heat exchanger of a boiler. You can go with the tighter mesh of that strainer, but you're going to make this worse. So that's going to be even more pressure drop if you get to, you know, a finer mesh on a Y strainer to catch those smaller pieces rolling around in the system, and it's going to plug quicker. So that's why the primary dirt separator is the best place to catch that stuff. And you're going to get stuff down to like the diameter of your hair with the dirt separator. Maybe not on the first pass, it might be on the second or third or 10th pass that you get those little particles, but you're going to get smaller stuff than what you would get with a Y strainer, kind of showed in the bottom right corner here, down to smaller grains of sand and rust. And then magnetite will be kind of the next thing that we talk about, that we actually have to have a third protection method with magnetite.
And we had another good question that came through here too, is can a dirt separator be installed on a bypass line to avoid line size? What do you guys think about that? I always call them kind of a side stream type filter or a dirt separator, but what do you guys think?
Well, it could certainly be, it's just going to take longer to do its job. There's going to be stuff getting through it the very first day that didn't make it, on the bypass, and that's in your system. I mean, better than nothing at all, I would say, but I would like to see it right in the stream. Now, some of the other brands out there, they show them as a side stream because they can't handle the flow rate. Their CV is too low, and you put it in there, you're going to restrict your flow. So if that's the case, if it's designed not to handle the full flow or whatever your system requires, then yeah, maybe the side stream is better than nothing at all. But no, we'd like it all to go through there. That would be my first choice.
Yeah, and I've seen the other scenario too, Bob, where maybe they just don't have the room for a full line size dirt separator in there, and at that point, like you said, a side stream is better than nothing at all. But ultimately, like you said, it's going to take longer to get all that stuff out of there. And, there's a better chance that other parts of your system are going to catch that debris first before it actually makes its way into the side stream. So
with a $2,000 ECM circulator that's on a big building, you don't want to jam that up the first day, put it in there.
You don't want to find the Lego guy in the ECM circulator.
Or the welding glove, yeah.
The welding glove, yeah.
And the other thing too is when you do look into a side stream type filter, I've seen a lot of them get installed where they just put T's and then they come off the side. In my opinion, there's got to be something in between those T's in order to push flow through that side stream. Water wants to take the path of least resistance, and I've seen quite a few of them where there is there's no restriction between those T's to force half of it through or 3/4 through the side stream or 30% through the side stream. So what's going to make it go that direction?
It's a low point dirt collector at that point. It's not.
Yeah.
It's not
well,
something.
hopefully, if it's installed in horizontal pipe, then then it's a low point. But if it's installed in vertical pipe, good luck.
Yeah. So probably not a best practice, but we've mentioned a couple of cases that it may be better than nothing. So let's talk about magnetite. So magnetite was something that was going to blow right through our Y strainers in a lot of cases. It's just too small a diameter to catch with a big mesh and a Y strainer, but we can draw it to a magnet. So where do we currently have magnets in a high performance system? Where else would we find magnetite today?
Circulators.
Circulators, yeah.
So this is an ECM pump. We had, so as kind of at Caleffi, North America in Milwaukee, we had a couple pumps fail and we took apart the circulators. We found this on the rotors and it's like, this building is, 20 years old, less than 20 years old. Why do we have this stuff? This isn't like a 100-year-old hotel or something with a bunch of cast iron radiators, but there just was enough magnetic garbage floating around in that building that we had some magnetic debris catch on the circulator, and then the pump started behaving poorly because it couldn't spin freely. It's water is cooling these ECM pumps with a big magnet right in the center of everything. So we need to have a better magnet to catch that magnetite first to protect the pumps and to protect the magnetite from cooking on the hottest points of the system, like a boiler heat exchanger.
I think the other thing to think about too is recognizing that the fact that it is a magnetite issue. I talk to a lot of contractors where they see a circulator fail. Do they really take it apart to the point where they can figure out that it was magnetite? Oh, heck no, they don't do that. This thing's a piece of junk. They rip it out and they put in a new one, and the new one's going to suffer the same fate. So you got to have a better magnetic separator before it gets to that.
Sometimes referred to as boiler ink. Like if you're taking a sample like in the picture there and it comes out looking gray or black in worst case, most of the time kind of gray, it's got a tint to it. And you say, oh, it's just dirty water from touching all the metal in the system. Well, actually set that on the counter overnight and come back the next day. And if it looks like the cup in the picture there, it's magnetite. It's not just dirty water from touching, cutting oil or whatever is in the system. So that's what you want to do is take a sample, let it settle out. And if it attracts to a magnet, whatever you have for a magnet, it's magnetite. And it's going to keep happening if oxygen's getting in that system, or if you got on the lower right over there a cast iron radiator that's been breaking down for 100 years and you put a new pump and a new system in there. It's cheap insurance for a system to put certainly if you're putting an ECM pump on, you should have a magnetic separator in the system.
Yeah, if you continue to get buckets of magnetite weeks and months into a system, the underlying issue is probably an air issue. It could be, these big radiators that you're just slowly bringing some more debris back from the bottom of those radiators that's collected. But if you have a bunch of magnetite every single time you blow down a separator, it's an indication of air that you have to address somewhere else.
For sure.
So what about a combined device? The short answer, we could spend 10 minutes on the slide or 10 seconds, use them for chillers. So there are some cases where it helps space-wise if you're limited to have an air separator and a dirt separator combo on a heating system. Ideally, we want to split those. We want the air separator in the hottest spot. We want the dirt separator in the dirtiest spot. That is the same spot for a chiller system because your warm return is going to be the dirty fluid from the distribution. So that's where we would use a combined air and dirt discal air and dirt combo like that. So this is a project that I worked on when I was a rep for Caleffi in Colorado, and they were able to address a lot of these things that we've talked about with a hydro separator, combining the air and dirt separator, still in the proper place for both. So the return is going to come back here before we get to the boiler pumps and to the heat exchangers. We're going to catch the dirt there, and then the hottest, lowest pressure before we boost back up with the system pump is going to be right here. So we're going to separate air and dirt really well. In this case, before they did this big renovation, the property manager had to go to every piece of fin tube baseboard with a little cup when they changed tenants, which may have been once a week because it's a big ski condo complex, and had to bleed out airlocks in all the fin tube baseboards. So then there's rusty water on the carpet, and it was this big mess. And they were able to prevent that from being an ongoing thing by just separating the air well before it left the mechanical room and catching the bulk and the entrained and the air dissolved within the fluid right there. So that's the best way to prevent an issue before you even have to deal with it at the different terminal units.
I know it was just Job or one of the other ones. There was actually a condo project somewhere there in Colorado where they actually drilled a hole.
I think it was this job.
Through the side,
yeah.
And they put little 1/4-inch copper tube off the bleeder L's on all the baseboards, and they would just pee it outside every time they had in there. Well, I'm not going to take a sponge up there every time. I'll just open it up and blow it out the side of the building.
So yeah, imagine the property managers rejoice when they didn't have to do that anymore.
Or somebody walking by that building when he's opening up and
yeah,
water peeing out the side of the building.
So a good fix to something that had to be purged all the time, but best case scenario is we just prevent that from being a daily task.
And also in that job right there, notice you can't quite see them, but there's variable speed pumps on the distribution just out of the picture there. And those boilers also have variable speed pumps on them. So the flow through that hydro exchanger is always changing, depending on what the load is. One boiler's on, two boilers on, they're up to high fire, they're low fire. The distribution pump is only going to a couple condos. So that's the beauty of a hydraulic separator, where your two flow rates on your boiler side and your distribution are constantly changing by quite a bit from one side to the other. So,
and that's where a tangential separator would work really well with 4 boilers on and with the pump spooled all the way up, but maybe not as well at a lower flow rate. Yeah. Okay, so let's talk about the next piece. So for the AutoFill, here are a couple cutaways. Cody, do you want to kind of narrate what happens inside of these devices?
Yeah, so, to kind of bring this full circle, the fact that anytime you have air removal in a system or dirt removal in a system, you're blowing down dirt and debris, you're going to have something to make up that volume of air or that volume of fluid that got blown down from the dirt separator. And that can be done with an automatic type fill valve like our AutoFill. These particular products are very common on everything from residential to commercial type applications. The idea is that it's basically like a pressure reducing valve that maintains a specific pressure downstream to make sure that that system is full of water. And so again, you start bleeding off air or blowing down dirt separators. A device like this is actually going to bring fresh water into the system. Now, it's kind of a double-edged sword. You got to think about that. And we've seen this happen quite often in leaking systems where they continue to leak somewhere where it's not noticeable, or it's under a slab or something like that. And these devices will continue to bring in fresh water. Well, that also brings in fresh oxygen and possibly debris as well from whatever your potable connection is. But the idea is this will maintain that particular pressure inside those systems. But really easy to use. You got a backflow prevention device to make sure the water goes in but not back out again. Really cool product here with our AutoFill. Very easy to set, very easy to adjust. We've got them for residential and commercial sizes.
So where would you see one of these come back? What's the symptom that you would see this as a return?
Oh, geez. All right. So just coming from the field myself, and Bob, you can probably relate, the biggest reason why we get these devices back is because the backflow preventer drips on the ground. Is that right, Bob?
Yeah, they drip or they spit or they go off. Yeah.
And really, in all reality, especially like the consistent dripping type ones, it's not a testament of product quality. It's a testament of the water quality that's going through there. And really, the fact is that if it's dripping on the ground through that vent between the two check valves there, it's actually because it's doing its job, which is the silly part. And people get upset and they put in a new one. The new one does the same thing. Well, maybe it's an issue with the fact that you've got a lot of dirt and debris coming through there. And if it can't seal around those checks, it's going to drip. And I would also say that anytime you install one of these things, make sure to not put it over really expensive pieces like your boiler, relay controls, things like that. Keep it away from things that are going to be not so happy about getting wet, is what I would say.
The code tells you you're supposed to put a discharge tube down to the drain or the floor out of that. That's why it's threaded, so you can do that easily. But rarely do we see that. I mean, commercial jobs or something, it's more apt to see a copper tube, placed in that and taken down to the floor. So, and the other thing that can cause a backflow preventer, any brand, by the way, to spit occasionally is a pressure spike. So if you've got a job where they've got high pressure maybe coming into this building, and you've got a fast closing valve like a big laundromat with a solenoid or a lawn sprinkler, something like that. When you shut off a valve really quickly like that, you can get what's called elastic shock. And what'll happen, and in fact, I don't know if we put in here a Vega slide where they did some testing, and they took 30 pounds of pressure and saw it go up to almost 500 pounds pressure when they hammered something off real quick like that. But when it does that, it'll go up real high, and they'll actually droop down below whatever the pressure coming into the system is. So it can go down to zero sometimes, and that's when a backflow preventer will just spit. And if you happen to be there when that water hammer bangs like that, you'll see it spit, spit, spit. And we did this for Shop Talk. I think in one of them, we actually, showed a demo of that happening where we just kept closing off and letting it bang. So again, it's doing its job, but you need to fix why that water hammer's in the system. Put a water hammer arrestor at the device that's causing that. We've heard some people say, well, they just put a swing check upstream of this backflow preventer, and the swing check will take the hit from the pressure spike and it won't hit the separator. Now you've got 3 check valves in a row, but if that's what it takes, I guess.
Got to do what you got to do.
Yeah.
Okay, so here are a couple different combinations depending on the size of your system and if it needs to be a testable RPZ style or press connections on a larger diameter depending on how much water you need to fill in a commercial system or something like that. So let's talk a little bit about the purge cart and then we'll move on to the shop talk. So is the system pump a good pump to fill and purge a system?
If it's sized right, probably not. In most cases, in most cases, these circulators are sized for lower velocities, so it keeps the velocity noise to a minimum, and they're still good for moving around air. But if you're talking about purging out systems for dirt and debris and things like that, a lot of times those circulators they don't have the velocity, through those systems to be able to push that stuff around. That's where a flush cart.
Typically 2 to 4 feet per second is the accepted velocity in hydronic system. What we've learned from the professional purgers, you got to get over 5 feet per second to start moving stuff like dirt or gloves or Lego or whatever it might be. You got to get up over 5 feet per second, and your circulator is probably not designed to do that. And so either you got to have a fill valve like the one we just showed you that can allow 5 gallons a minute into that system, or in some cases you might have to go even bigger with a pump like this that can pump 12 gallons per minute like this and get some pretty good velocity to really blast that water out. I mean, you can use line pressure. You keep an eye on your pressure relief valve on your boiler, hook up a garden hose, and with 60, 80 pounds of pressure, you'll get a pretty good flush, but you gotta keep an eye and make sure that you don't pop your pressure relief valve on your boiler when you're doing that. So the bottom line is you just got to get a really good flow. Now, if you had a system that you could break it down to one zone at a time, okay, I'll do one zone and the next zone and the next zone, which could take you all day to do that, you might get away with just, you know, the pump or with just the fill valve. But when you start talking 1.25" piping and stuff like that, you're going to need a little bit more horsepower.
For sure.
We can help you.
I've also seen guys too where if they need something a little bit bigger, there are some wholesale houses that'll even rent out like geothermal flush carts and things like that, where they've got even more gumption behind them, you know. And so definitely look into that kind of thing if you need something that's going to be a little bit more. And I'll even backtrack a little bit. You know, I have a lot of customers that will come to me and say, Cody, I want to put in one of your magnetic dirt separators because I'm afraid my heat exchangers are going to plug, and you know, foul up circulators and everything, and that's fantastic. But the other thing to consider is if the, you know, the dirt separators are only going to catch what comes to them, you know, and again, if your circulators are sized appropriately, you don't have that velocity to push it around. So, you know, maybe a magnetic dirt separator is part of the solution. Maybe another part of it is the fact that you need to do a good purge on these systems. Then you also got to think about the fact that the dirt and debris doesn't just show up on its own. It's a lot of times has to do with oxygen and corrosion, and you need to address that as well. So if you've got continued issues like that, there could be a lot of things involved there, not just a kind of one single easy button. So.
All right, so we've reached the part of the presentation where Cody and I are going to have a family argument. So I most recently, I worked for a manufacturer before this, but before that, I worked for a manufacturer's rep. So we would sell boilers like the nice, beautiful boiler that we've got on the wall back there. Cody, you came out of the field before this. So I'm going to argue that you should close this AutoFill. I'll back up a slide here. So the AutoFill has this nice gray knob on the bottom that you can tighten that up, and it's going to close the fill valve. It's going to prevent it from filling automatically after you've got your system up to temperature and up to pressure. Cody's going to argue that you should leave it open. So Cody, tell me why leaving it open is a good way to go.
Well, when you get done with a job and you get it purged out the best you can and everything like that, and you say you close it off, now all of a sudden that system's running, you start taking out air, you start taking out volume, and instead of being able to add more fluid, your pressure starts dropping. And then all of a sudden your low water pressure cut off and everything else in your boiler, the whole system shuts down. That's a callback right off the bat, okay? Not only that, I know exactly what you're gonna say, Max. What happens if the system has a leak? Okay, well, I'm going to tell you that the referral money that I get from the remediation company for all the water damage is worth a lot of money. So I don't want to close off that fill valve. I want to leave it open. No, I'm just teasing. The fact is that you got to be able to fill that system up with water when you're doing that stuff. You know, getting rid of dirt and debris through a dirt separation and air through the air separators. You got to keep that valve open. The only time I would say that I would highly recommend closing it is if it's a property that's not continually occupied, you know, vacation property that you're not there all the time, you know, that might be a good one. But if it's a primary residence, you're there all the time, chances are if there's a big leak somewhere, you're going to know it.
So Cody knows when you're home, so that's helpful. He knows when you live in your house and when you don't. He's got like a little ring cam that he's checking in on to make sure that you're fully occupied, or else he's going to go back and turn the AutoFill off.
Or if you're naughty or nice.
Or if you're naughty or nice. So what I would see sometimes, and it's like just an absolute heartbreaker for the contractor, for really the wholesaler, the engineer, everybody involved, the manufacturer, the rep, is sometimes if there's an unaddressed air issue, if there's a leak, hopefully it doesn't freeze and you don't have water, you know, filling on top of your, you know, art collection or something like that. But if you keep introducing that fresh water, it's bringing in more minerals all the time. So if you've got just a drip somewhere that you can't even see, it's in the slab, it's in the concrete, you're bringing in more and more minerals and you're filling that boiler up with sand essentially. So the longer you do that, the higher the likelihood you get to a catastrophic issue, which is that you have to replace the, you know, multi-$1,000 heat exchanger in a boiler. So it's a drag to have to go back for a callback. It's a bigger issue if you have to go back and be like, I'm sorry, Mr. and Mrs. homeowner, that, the heart of the system there, we have to throw it in the garbage, and it's not going to be covered by warranty, and you're going to have to put in a new one. So Cody, I can see.
No. See, so here's another thing to think about. Okay, say you close off that valve. Okay, you have a leak somewhere and you're not home. Okay, it's going to leak out a little bit. It's going to be all done, but then all of a sudden that pressure sensor in the boiler or the low water cutoff is going to take it offline, and then you're just going to freeze literally everything else in the entire house. So be prepared to buy all new toilets and all new piping and repipes, and it's going to be a nasty disaster of a mess. So I mean, I would rather deal with one little heat exchanger issue than having to repipe an entire house and replace all my toilets. I don't know. That's just me.
Well, maybe the middle road is to have one of those water shutoffs on the main that would detect if there's.
See, yeah, that might work. Yeah.
If you forgot to solder a pipe and a week later it comes apart, at least you're not getting 5 gallons a minute coming out of your ceiling. The water detecting solenoid will shut it off. So
yeah,
it's got to find their comfort zone on that.
And
you could leave it on
you're,
for a week and then go back a week later and shut it off.
well,
it sounds like Bob agrees with me there, Max. That's what it sounds like from here. I mean,
like we talked about, if you did that first purge where you get the system up to your design temperature in April, you shouldn't need those extra glugs of water for that first week. So you should be pretty set up to that temperature. Again, I want to know that there's a leak as a service contractor and as a homeowner, instead of having a time bomb of a very expensive dirt separator that you've created that's going to fill up with scale. And every new molecule of scale that's going to accumulate is going to reduce the performance of that equipment too. So you may start with a sticker efficiency in the 95s, not if it's all scaled, not if you've got more scale coming in every single day. So that's my closing argument. We're at the top of the hour, so we should launch the poll here. Anything else from you, Cody, before we get an audience vote?
We had a great comment from before we even started this. The idea to put a water meter on the feed from the potable going into the boiler. That would be, I mean, it's the same idea as that automatic shutoff valves for your, for your whole home and everything like that. If it leaks, at least you know it. So.
And they're cheap. You can get a plastic water meter online for like $50, so why not?
Thanks for agreeing with me, Bob.
Let me launch the poll. The pre-submitted questions that we had from Michael Ridler too. He's like, we posted this on LinkedIn, and it was, oh, this is a different poll. This is pumps or valves.
Yeah,
I got to do a different one.
Let me talk about water quality a little, because I know there's a couple questions about that coming in while I look through the poll. Is the pH is one thing you want to test. You can get strips if you've got good eyes to see the color. You can get a little test meter for that. You want to know the conductivity of the water. With these multi-metal systems, we got to keep a pretty tight range, especially with aluminum in there. You want to keep that pH about 8. So if you put a chemical like a Rohr or Fernox or something like that, you're going to be in the 7.5 to 8.5. Check it yearly. If that pH is dropping, it tells you got a problem in there. The conductivity is the same thing. Check it the day you put the fluid in there, come back if it's changing. If it's dropping or going up, you've got water being introduced, or you got a problem with corrosion in that system. So the 3 things about water that we want to address is there's dissolved solids, there's suspended solids, and there's also dissolved gases. We talked about the gas with the purge, we talked about the dissolved and the entrained solids that we can get out with the dirt separator. But that's the main thing about water. I think I will show a link here of a good manual that tells you a little bit more about, if you're going to start using chemicals, what to look for and how to test it. Because once you put a chemical in there, you got to use their test kit to tell you that, the inhibitor needs to be boosted up or the pH is dropping. So.
Okay, so I did not load the poll right. So here's what we're going to do. Pumps means Cody, valves means Max. So that's what we're going to do. Pumps means leave that fill valve open, let the water pump in. Valve means close that valve and leave that fill valve closed before you leave the job site. And I think it's going to be a photo finish here. We had a pre-submitted from Michael Ridler too. He said with this exact same question, well, are you talking about code compliance or are you talking about best practices? And there are some cases where it's like, well, I don't know. If the inspector requires you to leave that autofill open, even if you choose to close it, that you've got a little bit of a conundrum there too, because you don't want to fill it forever if there's a leak, but you also have to get occupancy in that building and make the inspector happy. So I am sitting at, oh jeez, let's give it to
You're just going to let it keep going until you win, right, Max? Is that the plan?
I'm going to close it here, I guess.
Oh,
so let me share the results here.
And
we ended up with a 50-50
Neck and
And we had
neck.
59% of the call vote too. So that wasn't even like we only had, 2 people on the call vote. So I guess we'll have to do this one again another day. I was watching it as it arrowed right there. So okay, that's kind of the main material here. Do you want me to skip, since we're at the top of the hour? Let me skip to that water quality one that you had for just a second.
We're a couple minutes late, but because I know a lot of people are asking about water quality, and it's a big topic. There's not just one simple answer that, okay, if you do this, your system's going to be fine. First thing you want to always do is check the water that you're going to use. I mean, 3 meters can do that. Your pH meter, you can get a conductivity meter, and a hardness test kit. You can buy those on Amazon for $35. You can get the drop, shake it and see. You don't want to put water over 7 grains per gallon hard in any system, in my opinion. You want to check the pH. You want to be above that 7 or boost it up and get it there. And you want to get the dirt and junk out of that. So we had a
So one thing before we get to that point, and we have another video about this on Shop Talk, but one compromise that I think Cody and I would probably have would be like a glycol feeder. So let's say you do need that extra gulp of glycol that's already pre-mixed to exactly what you want, 50/50 blue or whatever. Instead of filling from the street forever, you can just pull a cup of that fluid out of the glycol feeder, and that's a good way to go, because you can go back a week or a month or a year from then and see, okay, we filled a full gallon, or this thing is dry, we need to find a leak, but it's not something that's an emergency callback on New Year's Eve or something like that. Okay.
Yep. And
Yeah,
I would say too that with those glycol feeders, there is a means of kind of building those as a DIY as well. So I mean, if you're a little crafty, you can do that as well. Bob, I think you called it the glycol pig. That was on that slide just beforehand. Yeah, you're basically using the acceptance volume of the tank to kind of act as a reservoir for any time you have a volume loss. So same idea. You're limiting the amount of fresh water that can come in.
put 50 pounds of water pressure in that expansion tank and then put a fill valve on it to regulate it at whatever you want, 12. And now you've got about 3.2 gallons you'll get out of a number 30 expansion tank for backup. So
Yep.
Yeah, and that would be enough to do that cold weather fill. Then for the different water quality things here, let me just skip to this.
yeah, I mean, this
slide.
just shows you, this all comes out of that. I think it's still on their website. If you go online, there's probably a similar one from 80, and maybe Fernox have a manual that tells you a little bit more about water quality. There is an ANSI standard that we developed for water quality for boilers that's out there now. Again, it's just kind of a vague guideline that doesn't tell you do this, this, and this. But we had Jeff Persons on years ago, did a water quality webinar coffee for Caleffi, and he said, you don't have to buy an expensive meter to detect conductivity. He said, take your own meter, and he fills his systems with deionized water, geo systems. He said, I just stick an O-meter in the site water, and if it's bad, he said, I'll bring water with me the next day to fill it. So that just kind of gives you an indication of what you would read on an O-meter, stick it in water with a lot of minerals in it, or deionized water. Okay.
Okay. I think that brings us to the end here. So that's a recap of what we talked about today. We ended up with a 50-50 split on the vote. I feel like I think you beat me pretty soundly the last time we did this, when we did the Shop Talk Showdown. So to wrap up, we've got the tech support team. If you want to talk to a person about whatever's going on in your system, you can call us, and one of the team members at Ask Caleffi will pick up and walk through what's going on with your system with you. We have some of the ripped from the headlines tech support calls from Dan and Greg. They do a podcast with guests to talk about what's going on out in the field.
Giveaway.
And we have to do the giveaway. So this is a video series that Cody does. Let's pick a winner for the
I had one in mind. I've been keeping track of all the questions here. We had a couple of good ones here. Do you want me to announce the winner?
Here.
Yeah, you've been watching.
It looks like he's still online here. I think some of the greatest comments and questions came from a gentleman by the name of William Vanderslice. And so William, we're going to be in touch with you to get you a gold standard kit, get you an air separator and a dirt separator, get you the connection size that you want, whether it be sweat or NPT or sweat or press, excuse me. And again, we'll be in touch on that one, William. And yeah, I think that's about it. Check us all out on social media there too. We've got a lot of great stuff, whether it be new product information. We always like to see your installations too, so definitely tag us. If you're doing installations, you're working on any projects or whatever, tag us on Instagram or Facebook or whatever, and let us take a look at it. We always like to see what's going on out there for sure.
Well,
Yeah.
we'll get to the questions that we didn't cover. I know there's some
we
pre-submitted
had a
ones we
bunch.
might not have covered, and some of them that came in. So between the three of us, we'll make sure that we get an answer for you.
And specific to that gold standard kit, they come with a sticker, and you can tag on the social feeds hashtag Caleffi gold standard. And what we want to see is you protect the systems, because we never want to see this type of end result.
Yeah, don't you put that back to us. That we didn't do that. You did that. That didn't need to happen like that.
But that's
if you want all that dirt and debris in there, we charge extra for that when we ship it out of the warehouse. So
You got to ship. Yeah, the shipping costs to go
Yeah.
up if we send it.
all right. So happy holidays, everyone. We'll see you in February. We're taking January off for the AHR show. We'll be back with John Siegenthaler in February to talk troubleshooting with hydronics again.
Yeah, that'll be a good topic. That's going to be a popular hydronics issue, I think.
for sure. Thanks for your time, everybody. Have a great holiday. See ya.
Thanks, everyone.